Hello, this is the first part of the Arduino-based lectures and experiments, which will be, of course, the foundation for the project this semester. As you see here, I'm just showing the document related to Chapter 7, and the first part is about how to download and install the Arduino IDE. In this case, that's the latest version at this time, and that will allow you to communicate with the Arduino through the programs and have the ability, of course, to also have access to the external world through the circuitry to be able to control a given application. So as you see here, once you download, then of course when you try to install, then of course there's the license agreement and you have to agree to it. And in this case, of course, whether you will allow anybody to use that application or just you. In this case, there's nobody else on this computer. Then we choose the location. Obviously for me, I just chose the default. And obviously then you end up with a program that shows, in this case, a program that I had written before, but in your case, most likely, is going to be a generic type of opening program, as you see here, that you have the format for some of the steps that you have to insert as to be able to write a program. This is setting up the characteristics, the specifications for the input, output, and other types, and what have you, and then the program itself here. And before that, you will see that we also have a capability of labeling and constants and variables that we can assign values to. And the reason is, for example, if I want to use pin 2 from the Arduino as an output, but then in my program it gets involved in so many other steps, right? So if I change the output to the output pin to 5, then I would have to go through every step in the main program to change it. Whereas if I declare it as a constant through a variable name, then by just changing the value assigned to that variable name, it will change the entire program, right? So in this case, to be able to run the programs associated with Arduino, first you have to go to Tools and you have to choose the board. So in this case, it depends on the computers, it depends on the boards themselves. Sometimes there's the original Arduino that are compatibles. In some cases, the software will be kind of plug and play, meaning it will recognize the board and automatically it will tell you that the board had been recognized. Whereas in this case, I had to go to this choice here and select Arduino Uno. And then after Arduino Uno, I also have to select the port through which the Arduino communicates with the PC. Most of the time, if it's again plug and play, the board would be associated with a specific COM port. But in my case, for example, I had multiple COM ports available to choose from, but there was no Arduino associated with any one of them. So the only way for me to be able to figure out which port has been associated with the Arduino is to just take any program and try to upload it. If it doesn't upload, then I know it's the wrong port. If it does upload, like in this case COM6, then that happens to be the port through which Arduino communicates with the PC. So, one thing that I wanted to also remind you of is that something that is special to this kind of programming is that whatever program you write and whenever you save a file, it has to be saved in the same folder, in a folder with the same name. That means through Arduino here, that's the folder, the main folder. And in that folder, I have multiple programs. And each program appears as a folder, like in this case, Blink, that's the folder. And in it, I have at least this one. So there could be other files, but in this case, it's a simple program. So the only thing that will exist in that folder would be my program. So again, the program name and the name of the folder have to be the same. So I have different applications that that are shown in the manual, right? I'm just gonna go through them and showing you in the circuit where it is, right? What it does, how it is connected, and so on, just to guide you a little bit. I'm sure after a while you don't need any more guidance, but then you can also find that there are hundreds of thousands of tutorials and sample programs in YouTube and the internet, right? And not just YouTube. YouTube, they show you the videos, and the internet, they can show you documents that provide you with different usages of this microcontroller and in different applications. So hopefully it will inspire you on how to conduct your project, because then you will be able to come up with an application that hopefully will be, if it's not innovative, at least interesting and different from other people, so that it's not just a copy of the same thing. So if I go to the microcontroller, what I'm going to do is I'm going to upload this program in the microcontroller, right? So in this case, for example, and let me see, where is my my Arduino? Here it is. So in this case, I go to the program itself, and as you see here under Tools, I have Arduino Uno already chosen. I knew that COM6, as you see here, was not exactly very visible choice for the COM port. Most of the time, the name of Arduino will appear next to the COM to which it's connected, but not in this case. So I assume that has been done. And so when I upload it, so I go to this one here, to this this arrow, from left to right arrow, that's uploading. That means the program will be transmitted into and stored in the microcontroller, and it will run automatically. So at some point, as you will see, everything stops, and as you see here, this LED, which is of course protected by this resistor, in this case 100 ohm resistor, it doesn't matter, somewhere between 100 to 470 ohms. The output pin that was, in this case, the LED was decided to be 10, so that's the 10 output, the digital output 10 pin from the Arduino, connected to the anode of the LED, and the cathode connected to resistor, which is connected to ground. And so as you see here, it's blinking at the rate of, in this case, even though it says 100 that I chose for time, which means 0.1 second, right, 100 milliseconds. But here, I just show you something that if you wanted to change the time without changing the time itself, right, maybe we have a standard time of 100 milliseconds or 1000 milliseconds, and then you want it to be longer, you want it to be shorter, so you can just multiply by some number greater than 1, less than 1, and it will change the delay. That means this loop will run after this much time, every time. And so in this case, 5 times 100, that means 0.5 seconds. That means 0.5 seconds, and it will go back and do the same thing over and over. That's why it's called the loop, right? So in this case, that means it's gonna go and turn the LED high, and in this case, the time that it stays high is only 0.1 second, but then when it goes low, it goes at the time of 0.5 seconds. So really, when you look at the loop, it's not 0.5 seconds, it's about 0.6 seconds, because 0.1 for the LED to be high and 0.5 to be low, right? And that's why it will just turn on like for 0.1 seconds and then turn off for 0.5 seconds. So it's just a different way of looking at things. And I hope that I will have a second recording that will show you other sample programs from the chapter 7.